Every routing protocol has got a metric. Only based on the metric, the best path is elected. Only based on the metric. Except BGP. Except BGP. All routing protocol have got a metric to decide the best path. Understand? Except BGP. All other routing protocol has got some metric, which means BGP don't have metric. Yeah. So when we use metric like hop count in RIP, the path with the small metric is the best path. What if I have multiple paths with same hop count? Load sharing is done. We consider it as equal cost path. RIP supports load balancing. Equal cost load balancing. EIGRP also supports. OSPF also supports. ISIS also supports. Wherever the metric is same for a destination, whichever the route that has got the same metric for the destination, all those routes will be used for load sharing. That is equal cost load balancing. Up to how many? By default it is 4. By default up to 4 paths can be used. Even if you have 100 paths, only 4, any 4 that will be picked randomly will be used for load sharing. So this is seen in RIP, EIGRP, ISIS, OSPF. Only up to 4 by default. But you can have up to 32. Olden day it was only up to 6. Now you can have up to 32 equal cost path for a destination in a routing table. 32. Definitely this number will grow bigger and bigger when a protocol is recommended for cloud. Cloud network is internet. Hundreds of routes will be available. So if you will be able to use all those hundreds of routes for load sharing, then the communication is going to be faster. So definitely this number will increase. But again, I'm telling you, the cost need to be same. You can also change this number of routes per destination in a routing table. I said by default 4, you can change up to 32. You can also change it to 1. So up to 4 you can tune, up to 32 you can tune, the default is 4. But you can also go down from 4 to 1 so that only one route will be seen in the routing table. Which means you are disabling the equal cost load balancing. You are disabling the load balancing. You say, I just want only one link, one path. So you can go down to 1, you can go up to 32. The default is 4. But you know one thing, this EIGRP is something special than other protocol. It can even support unequal cost load balancing. If you have only one path as the best path, but there are other paths in the feasible successor list, means there are other paths in the topology table with feasible successors for a destination. You can increase the variance number. The default variance is 1. By increasing the variance, you can tell EIGRP to consider the feasible successors as a successor. Let me repeat. By default, like other protocol, EIGRP supports equal cost load balancing. EIGRP can also do something better which other protocols don't do. What is that? It can even support unequal cost load balancing, but it's not by default. You need to configure variance. When you configure variance, then unequal cost load balancing is possible. Configuring variance allows the router to include the routes with a metric smaller than the multiplier value times the minimum metric route to the destination. What is the minimum metric to the route? Someone tell me. For a destination, the minimum metric route is called as what? Successor. Let's say the successor's metric, the successor path. What is successor? The best route. The low metric. The lowest metric path. Let's say the lowest metric path, we'll name it as path 1. For a destination is 400. 400. There is another path, path 2, which is 650. That's not minimum, no? 650 is not minimum. 400 is the minimum. There is another path, path 3, which is 850. Now, for these are all unequal cost. For load balancing using variance across the unequal cost path, we need to decide how many paths we need. See, if I want all these 3 paths, my variance value will be 3. Why? Variance is this 400 multiplied by 2. What is the answer? 800. But this is 850. It allows the route to include routes with a metric smaller than the multiplier value. What is the multiplier value? 800. I put variance as 2. What it has done is it has multiplied the 2 with path 1, the low cost path, the best metric, and you got a multiplier value. Now all the route whose metric is lesser than or equal to the multiplier value will be used for load sharing, will be considered as the successor. Before you change the variance to 2, what was the variance value? 1. When variance is 1, you multiply 400 by 1, you get the same value. You cannot do load balancing. When I put 2, what happened is, it became 800. So my multiplier value is 800. Any route whose metric is less than 800 will be considered as a backup path. Which means this is qualified. Now both this path will be seen in the routing table. Both this path will be considered as a successor. But path 1's bandwidth will be more than path 2. See, bandwidth is more, so metric is less. When bandwidth is more, metric will be less. So will it be doing sharing the load equally across this path? No. No. You don't share equally. If you have 1000 packet to send, this may be carrying like 700 packet. This may be carrying 300 packet. Why? Because the capacity is different. Here less bandwidth, so you got 400. Here here more bandwidth, you got less metric, 400. You got less bandwidth, so more metric. So according to the capacity, EIGRP will decide how many packets via path 1 and how many packet via path 2. We no need to do those things. EIGRP will take care of it. Now tell me, if I want to have all these 3 paths, what should be my variance value? If I want to do load balancing on all these 3 paths, what should be my variance value? What happened? 3, that's all. Very good. So when I make this as 3, I get 1200, and now these all 3 are qualified. I'll get 3 successors now. So the variance you only decide. When you see some routes in the topology table but not seen in the routing table, what is the reason you don't see in the routing table, you see only in the topology table? The reason is it's not lowest metric. It has satisfied the feasibility condition, but it is not lower comparatively. Lowest metric path will be seen in the routing table. The other paths that satisfy the feasibility condition but not lower, not the lowest one, will be seen only in the topology table. Now those paths can be utilized by changing the variance. When you change the variance, those paths which was only in the topology table now will be seen even in the routing table. So you got route in topology table as well as the routing table. The routes that are in the topology table is not guaranteed that it will be used for packet forwarding, but the routes that are there in the routing table will always utilized. If route is not there in the routing table, it will not be used for packet forwarding. You may have 1000 routes in the topology table. It's of no use unless you see those routes in the routing table. When the routes are there in the routing table, only then packet will be forwarded using those routes. So before configuring variance, the routes were those 3 routes. Out of those 3 routes, 2 routes were in the topology table only. Path 2 and 3 was only in topology table. But when I put variance 3, that 400 is multiplied by 3 and I got 1200, and my path metrics are not more than 850. So you will see all 3 in the routing table. So keeping things that I have explained you in your mind, go through this example. I'll give you 2 minutes. Go through this example. I'll ask all of you one question each. You need to answer. So from A to B you got different metric paths in which these 2 are equal, no? So in the routing table you will have this path and this path. You will not have the other 2 paths. By default, variance is 1, which means 10 is multiplied by 1, 10. So all those paths whose metric is 10 or less than 10 will be used. Because these 2 paths satisfy 10, both will be seen in the routing table. You don't need to configure any variance for this. The default variance is 1. Now, in case if I want to have this path and this path also in the routing table, assume that those other 2 paths satisfy the feasibility condition. They are right now there in the topology table. That is very important. The 3rd and 4th paths are in the topology table now, but it is not in the routing table. If that is the status, you can change the variance. You can change the variance and you can have the routes. When I change the variance to 2, what will happen is the lowest metric 10 is multiplied by 2. I get what? 20. So any path whose metric is less than 20 or equal to 20 will be used. So this path will also be used now. But this path cannot be used. Why? Because it's bigger than 20. So if you want this path also to be used, then you should have said variance 3, not 2. If you'll say variance 3, only then you get 30, 10 to 30. Now any path whose metric is less than or equal to 30 will be used. This is also going to be used. So now all 4 will be seen in the topology table. Did you understand now?
Yes, sir.
When the variance is default, how many paths was used? In this topology, this example I showed, when variance was default, how many paths were seen in the routing table?
2.
When variance is 3, how many paths are used?
4.
When variance is 2, how many paths are used?
4.
When variance is 2, when variance is 3, it is 4. When variance was 2.
Okay. Variance is 2, 3, only 2.
What happened?
3.
3. These 2 and then this one. Alright. So now with that understanding, go through this example, and when you are ready, let me know. I'll ask you a question. Alright. See, when the variance is 1, from E to Z, which path will be used?
Path C will be used.
Why?
Because when we multiply the...
Because the feasible distance is lower. Lower. Next question. When the variance is 3. When the variance is 3, how many paths will be used? Not I want someone else to answer. When variance is 3, how many paths will be used from E to Z?
3 paths.
I say 2 paths only. Why? Anyone has got answer why?
Maybe because the D does not fulfill the feasibility criteria.
Correct. You see, if I put 3, 20 multiplied by 3 is 60. This is less than 60 only, but it cannot be used. Why? This will not be seen first of all in the topology table. The advertised distance should be less than the successor value. It is not less. 25 is not less than 20. So this won't be seen in the topology table. Even if you put variance 3, that route cannot be considered. You understood, Joseph?
Yes, sir.
So don't try simply increasing the variance. It's not going to meet your need. Only these two will be seen in the routing table because the advertised distance is less than the successor value. When you change variance to 2, 20 into 2 is 40, so this is less than 40, it will be used. Even if you change to 3 as variance, that won't work because the advertised distance is not less than the successor value. It didn't satisfy the feasibility condition. That's good. Alright, so this is what we need to test in our lab environment. Yeah. So for unequal cost load balancing, we got this topology, and this topology is used in the previous class. So according to me, the configurations are already done. Before we get into that, let's see what is by default. By default, if you see, the number of links between router 1 and router 3 is only 2. 2 links here, 2 links on the top, 2 links on the down. And they are all in same speed, gig Ethernet. So it's going to be equal cost path. But what I did is, I did some changes to the bandwidth so that it will become unequal. You understand? Unequal. At the same time, it has to satisfy feasibility condition. That I have done. So as a result, if you see, on R1, show IP route EIGRP, to reach that 3333. Right now I have only one route via router 2. Only one route via router 2. But if you see in the topology table, show IP EIGRP topology, I got 2 routes. One via router 2, the other via router 4. And see, the metric is not same. This is lower than this. How? This is 35, this is 38. 3584. So right now you have only one successor. You understand what I am saying? Do you follow? For this destination, I got 2 paths with unequal metrics. Do you see that?
Yes, sir.
and the metric with lower is elected, which is wire router 2, and that's the current successor. This 3333 is where? On router 3. Joseph, do you understand? What happened to Joseph? Is he offline?
Sorry, sir. Yes, I understand.
So show IP route will show you only one route via router 2. Now if I want both the routes to be seen in the routing table, I need to see what number to multiply with this so that the multiplier value will be greater than this. If I multiply this by 2, I'll get some 7,000. Agree? If I multiply that by 2, I'll get some 7,000.
Yes, sir. Yes.
Yes. So, when I do that, you will see two successors. Right now, it is only one successor. So, let us go and change the variance. Right now, you see the default is show IP protocol. The default variance is 1. Simple command, no? Show IP protocol. It shows all the routing protocol. It shows EIGRP is the only protocol that we run right now. And the variance is 1. See, maximum path supported is 4 by default, but I told you it can be up to 32. Router EIGRP, what is the number? 100, no? 100. Max path command. You see? You can go up to 32. Whatever the variance you may change. If you want only one path, then you can set 1. Even if variance is changed, it's of no use if the max path is set to 1. Anyway, that's not our story. Our story is we want to use multiple paths. The default is 4. We don't have more than 2 paths. It's okay. Let it be default. We don't want to change. If you want to change, you can change and see. You see, I changed to 32. Now you see it's 32. Now let's go and change the variance. Currently there is only one route via router 2, but when I change the variance, router EIGRP 100 variance, you can go up to 128. I'm saying 2, simply 2. Now I want to show you the routing table. Show IP route. Look at this. To reach 333, you got unequal cost. You can now go via router 4 as well as 2. You see, router 4 is down path. Earlier it was not there. Now it is there. Earlier only this low metric was there. Show IP topology. Show IP EIGRP topology. You see, you got. Actually, it should say 2 successor. I don't know. Some operating system shows very clearly 2 successor. See, that's what you see in the routing table, right? 2 successors. These 2 are successors. You understood how variance can change? Now let us check show IP protocol. You see variance too. Show IP route 3.3.3.3. You got 2 routes, one via router 4, another via router 2. Currently it is using 2. It will also use 4. When you have more traffic, it will do load balancing. Both are best paths. Both are best paths. So let us now remove the variance and come back here and see. You see, now it is only 1. When I put variance 2, You get two routes. So I hope that you understood how the unequal cost load balancing can be achieved by changing the variance. Any question?
No, sir.
All right then.